Alright, good morning class. Welcome back to chapter 6, 6.2 transformer. Okay, you need to know what is the meaning or function of the transformer. Okay, transformer is a device used to increase or decrease the voltage of an alternating current. Okay, means we connect the primary coil to the alternating current supply and secondary coil to the output. Okay, by using a laminated soft iron core. We use soft iron core because it can easily magnetize and easily demagnetize. Okay, so the primary coil always be connected to the alternating current supply. There are two types of transformer, step-up transformer and step-down transformer. So we look at the difference between step-up transformer and step-down transformer. Okay, we have the symbol. We can see the difference by using the symbol also. The symbol show you the type of the transformer used clearly, more clear if you use the symbol, because we can see the number of turns at the primary coil and secondary coil. So we have four symbols here: VP, VS, NP, and NS. Okay, VP refer to the primary voltage that we connect the transformer to the current, to the alternating current. That is VP, primary voltage, and then the secondary voltage is the output. So this secondary voltage or VS, okay, this VS will determine the type of the transformer used. Okay, and also it depends on the number of turns, number of coil at the primary and secondary. So look at step up transformer, the number of turns at secondary, NS is the number of turns at secondary. So in step up transformer, the number of turns at secondary is larger than the number of turns at primary. So if the number of turns at secondary larger, then the output voltage or secondary voltage is also large, will be increased. That is step up transformer. Meanwhile, for the step down transformer, okay, same symbol used also, NP, NS, VP, VS. So VP is always connected to the AC supply, connected to the current. Okay, then we have the number of primary coil. There, can look there, the number of primary coils larger than the number of turns at secondary coil. Means that the secondary voltage produced will be decreased, because number of turns at secondary is less than the number of turns at primary. So the voltage, the secondary voltage produced is also less than VP, input voltage. Okay, then we have the use of transformer. Okay, we use it in domestic electrical appliance. Okay, and the transformer use is usually a step down transformer, because we want to decrease the voltage that we receive from the substation, that is 240 volt. So we use transformer in a certain electrical device according to their needs. Okay, so let's for example, okay, let's look at the ceiling fan regulator. Okay, inside the ceiling fan regulator there is a transformer. So the transformer consists of secondary voltage, okay, primary voltage, primary coil, number of turn at primary coil and number of turn at secondary coil. So that 240 volt refer to the primary voltage connected to the number of turn at primary. Okay, now if we want to change the speed of the rotation of the fan, we just change the number of coil at the secondary coil. So you can see here there are 5. The fans can be regulated into 5 speed. Okay, so maybe from number 1 that use 2 volts, okay, you can increase to number 5 that consists of 10 volt. But this fan regulator is made up of step down transformer. Why step down? Because we receive 240 volt here, we want to decrease the voltage. Maximum use is 10 volts only inside the ceiling fan regulator. The maximum voltage is 10 volts only. Okay, so from 240 volt will be decreased to 10 volt. The smaller voltage is used in this ceiling fan regulator. That's why we use step down transformer. So the number of turns at secondary coil is less than the number of turns at primary coil, so that we can decrease the voltage, the value of the voltage. Now this is the equation for the transformer. The ratio of primary voltage to the secondary voltage is same as the ratio of number of turns of primary coil to the number of turns of secondary